All right, starting where? Starting where? 9. 9?
Yeah.
11. 7.
9, 10, 11.
12, 13, 16, 17, 18, 22, and everything after 9.
All right, number 7. What's your strategy? Nope. Bad strategy. Don't get reliance on that.
Plug in 0.
Okay, plug in 0. Fail. 0 on the bottom. What's your next strategy? Boil it out. Not at all.
Oh wait, I got -1.
Pascal's triangle, right? Right? So you can FOIL this out the long way by going h minus 1 times h minus 1 first, and then taking that result and multiplying it by h minus 1, and combining all your like terms. Or you can get happy with Pascal's triangle and know that the answer is going to be h cubed minus 3h squared plus 3h minus 1. Okay, way easier. Yes?
It doesn't matter if I don't have my things in order, like, can I do this with you guys?
Yeah, that's right. Okay, so either way you slice it, that's how you get that FOILed out. All right? So now the question becomes, the limit as h approaches 0 of h cubed minus 3h squared plus 3h minus 1 plus 1
Get rid of the left.
all over h.
The 1 takes. I think we get rid of
Because you told me I had to roll 2 back.
Right.
We're okay? All right, so the 1's cancel. Yeah, and conveniently that leaves an h in every term that's left. So I'm going to do this the official way because I'm a teacher and I'm supposed to. So that means I can factor out an h. Now this h and this h cancel. And now you can plug in 0 directly. And you get an answer of 3. Okay? Which you can also get from looking at the graph and looking at the tables. But there will be situations, like the AP Calculus test, where you may not use your calculator. Okay? So to better prepare yourself for that, you need to be able to do these algebraically when it's possible to do them algebraically. And this is one that you can.
Did you say on our AP test or our test?
On the AP test. Okay?
Wait, don't do it.
Okay. All right, yes, so your first thing that you should try and do always is just plug in the value. And of course you can't in this case because you get 0 on the bottom. So now we're going to do some algebra. So you know that t squared minus 4 factors into t plus 2 times t minus 2. That's the easy one. Remember when I gave you that note card and you wrote down the limit as x approaches 0 of sine of x over x was 1? That was our first important fact that we were going to reuse a lot. It seems to me that you might want to write down your cubes because this has come up a few different times. A cubed plus b cubed factors into a plus b times a squared minus ab plus b squared. And a cubed minus b cubed factors into a minus b times a squared plus ab plus b squared. That's come up a couple times already, so it seems like something you might want to have easy access to. So yeah, take your note card, copy that on that, tuck it into your book or into your binder, and then you won't have to ask me anymore. Another hint there is that 8 is 2 cubed, and so this is the difference of 2 cubes. So that's going to be t minus 2 times the first one squared plus these two multiplied together plus the second one squared.
And then if you say
And we did difference of two squares on the top. Yeah, and it wasn't even Raina that told us to do that.
It's just like your thing.
All right, so now, okay, the t minus 2's cancel. And then once again, that allows us to substitute the 2 directly in there. So you get a 4 on top, and you get 4 plus 4 plus 4 on the bottom. So that is 1/3, which again, you can get by looking at the graph. And we want to be able to do these algebraic, okay? This thing right here, from this formula right here. So my A and B were t and 2, so t squared, and then multiply those two together is 2t, and then square the second one is 4. Okay, yeah. I'm not going to make you show your work, but if you do this problem and you write down 1/2, and that's all you write down, the whole problem is wrong. If you do this problem right here, and I see all of this work, and then here you go 0, and the answer is 2/5 minus 1 point.
Because you should.
Because I know that you did the calculus correct, you just did one little bit math movement. But if you just write down 2/5, I don't know what, how you got that. Wrong.
So, but if you got it right. So, do it just like.
Just write a whole bunch of stuff. Okay, number 9.
Okay, this is where I'm going to do
All right, what's going on here?
Well, you can't plug that in.
Can't plug 9 in.
So,
Does it get 0 on the bottom? Difference of 2 squares twice on the bottom.
But even if,
what Leanne said, difference of 2.
but even if you do that, at least you have
Right, if you FOIL that whole thing out. Okay, so we could try doing complex conjugate here, but I don't think we're going to have any success
I
with
don't
it.
like that anyway.
Well, it's not very hard, it's just, right? But that's not going to, I can tell you right now, that's not going to get us anywhere, so don't even bother. writing that down.
Can you imagine what a good function is like?
You didn't say anything. Okay, I feel like we're stuck. So you can look at the graph. Would you like to look at the graph?
Yeah.
Okay. All right, so if you look at the graph of the square root of r divided by, I'm not sure what just happened there, r minus 9 to the 4th.
Can you make sure you put that?
What is going on over there where x equals 9?
It's infinity.
Yeah, we got an asymptote. And so, right, and so what Leanne just said is very important. It's infinity from the left and it's infinity from the right. And so both of them, what? Both of them are the same. And so the answer is infinity. Okay? Now it turns out that what Evan said is actually the way the book, the answer key says to do it. Just to do kind of a thought process. What's going to happen if r is a number very close to 9, either above it or below it?
Very small number is going to become a very small number.
Right, after you take it to the 4th. So if I put in a very small number that's a little bit less than 9, this is going to come out to be a very small negative number. But I raise it to an even power, right? And it's going to become an even smaller positive number. So what's a regular number divided by a really small number?
Really big number.
Right. And the same thing happens when you plug in a number just bigger than 9. This is going to be positive if you square, or to the 4th, I mean, it's going to be even smaller and still positive. And so when you divide that, you'll get infinity again. So that's kind of what you said, like visualize the graph or something like that?
Yeah.
That's not what you were going with? Okay. All right.
Yeah.
So sometimes you can look at it and you can think about what the behavior of the bottom function is and what the behavior of the top function is around that number, and then use that to figure out what's going to happen. Okay?
Yeah.
But, you know, that's kind of cheap. All right, number 10. Absolute value is not our friend.
I'm not sure how, did we scratch that?
So, what does the graph of the stuff inside the absolute value look like?
Straight.
Touchdown! No, but isn't it like this because of the
yeah.
negative?
Yeah, okay.
So it's going to be, is that true or is that not true?
That's true.
Is it true?
Because it'd be negative b plus 4 is what it really is. But it,
Right.
So it'd be over there.
So it'd actually be moved over to the left? And is it flipped upside down?
Yeah.
Are you sure?
No, definitely not.
No, because
Oh,
it's
sorry.
confusing me now.
Because
Too late.
it'd only be upside down if the negative is outside the.
Right.
Okay.
Well, I was the one that raised that question in the first place, so it's my own fault. What was it, 4 minus v?
That was on the bottom.
Okay, so it's just regular old shifted to the right 4, right? Okay. So if we want the limit as x approaches 4 from the positive side, we're looking at
What
only
about the
this.
stuff on the top?
Well, we'll get there in a second. If we want the limit as x approaches 4 from the positive side, we only want this branch right here, right? So what is the equation for this that we can write without an absolute value sign in there? What's the equation for this line right here? The y-intercept is -4 and the slope is 1. So we can rewrite this as the limit as v approaches 4 from the positive side of v minus 4. Okay? So that's the key to, yeah, I was only graphing the absolute value part, Mary. So that's the key to the whole absolute value thing, is to understand what side of the absolute value graph do you need. Okay? And then just rewrite it using that. And if you need both, then we'd have to do this limit, and then we'd also have to do the limit of the other branch, which would be negative v plus 4, okay? But we only have to do from the right-hand side. So what can I do with these things right here? I don't know what the whatchamacallit is. No, because that's only square roots. What is 4 minus v divided by v minus 4? -1, right? Because I can rewrite the one on top as -1 times v minus 4, right? Shouldn't this be 4 minus v on the bottom? No, because I want 4 from the positive side, right? So if I look at the graph of just the absolute value part, 4 from the positive side is this line right here. And so the equation for that is going to be y equals v minus 4. Okay, right. Okay. All right, so then these cancel, and I get an answer of -1. Okay. So the key there was we were supposed to be able to recognize that that graph just looked like that without cheating and using the graphing calculator. Because if we're going to cheat and use the graphing calculator, we might as well just graph the whole thing right from the beginning. I factored it out of here. So I took out a -1, which changed this 4 to a -4, and this negative v to positive v, making these two the same and allowing these to cancel. Okay?
Is that because you only want to know from the right side?
That's because I only want to know for the right side. If I want to know the overall limit, then I would also have to look at the limit as v approaches 4 from the negative side.
So you would want to make it
And then that
v
would
plus
be
4
this,
on the
right, then that would be v plus 4 here, which I couldn't doing, well, then I could just substitute it in there directly, right? And if I put a 4 in there, that would be 0 on top over 16, so that would give me a limit of 0. There might be, and so that means that the overall limit doesn't exist, right? Because the one from the right and the one from the left are two different answers.
So
Okay?
if it's from the right, you make it negative on the bottom.
Not necessarily. It depends on what is in the absolute value steps.
So how did you know to make it that?
Because I looked at the right-hand side of this and figured out what the equation for that one
Oh,
would
okay.
be. Okay? And then if you wanted to save yourself all this trouble by just doing it on your calculator in the first place, what is it? Is it x minus 4 on top?
That's why.
Yeah. No, it's not.
No, it's 4 minus 6.
Is 4 minus x on top?
Yes.
Curse you, Jefferson Bounder.
See, if the makes more sense.
Unless by having it in the bottom, you can cancel out.
Okay, so you can see the limit as x approaches 4 from the positive side is 1. Okay? Negative 1, sorry, which is what we came with. So, hooray for math. All right, am I keep just going?
Yep.
11. Okay. 11 does not look too difficult.
Yeah, it does.
Well, when you come out with 0 at the top.
And the bottom.
You do?
I didn't see 0 on the top, I had it in the top.
I have 0 on the bottom.
Yeah.
If you have 0 on the top and the bottom, is that
No
still
good.
impossible because of the 0 on the
Yeah, like I said, we'll figure out a way to handle those later in the class, but we have to learn how to do something else first before we can solve this. Okay, so this is the double difference of two squares on top that we like. So this will factor into u plus 1 times u minus 1 times u squared plus 1. Right? I just did 2 steps in one. Handle it. I think you can. I think you can. And then on the bottom, I can factor out a u. And what does that leave me with?
U squared plus 5u.
Well, but what does it factor into? U plus 6, u minus 1. Okay? So now the u minus 1's cancel. And then can't I just plug in 1?
Yeah.
So that would be 2 times 2 on the top, which is 4. And 1 times 7 on the bottom, which is 7. Okay.
Well,
You made that
what
look-
if you like factored out like the square plus 1?
What if you factored out the u
Wait,
squared plus
wait.
1?
No, I don't understand. I understand the theory behind it, but I don't know why I can
Okay, what did you factor the top into?
U minus 1 times 1 plus 1 times minus 1 times minus 1.
Okay, that's your problem. U squared plus 1 does not factor into u plus 1 times u minus 1. So you went too far. It has to be the difference of two squares, not the sum of two squares.
Okay,
Okay.
gotcha.
So then when you plugged in 1, yes, then you would
Yeah.
get 0.
Okay, thank you.
Uh-huh. I find that a lot in this class, that oftentimes the calculus is not too bad, but the algebra is where the problems
You
are.
went down this route.
When Mr. Helvey,
Right.
you had him for algebra? No, I'm going to blame that on you.
On us not remembering.
Yes, I'm sure that Mr. Helvey taught you to go back. Okay, are we just running the table now?
Yeah.
So are we looking at a test on Thursday?
Yes.
That'd be nice.
I want you all to do really, really well.
Now I can erase I think I never tried to do my assignment last night.
Yeah, good thing. All right, so this is a fun one.
Wait.
3 doesn't work.
Nope, 3 doesn't work.
So it's a really nice surprise when 3 does work.
You gotta do it 2.
What was it?
I think I want to multiply by the conjugate.
Yeah,
I would have back to the bottom first.
You would have?
Yeah.
All right.
So then it's already back.
Right. Yeah, then you can cancel directly. Okay. Okay, well, let's do them both at the same time. So,
I skipped 13.
so Connor says, well, that's not even hard. You can immediately factor an x squared out of the bottom. Okay? So rewrite that as x squared times x minus 2. No big deal. All right, now, what are we multiplying the top and the bottom by? You take the square root and make it negative, and the other thing stays the same. And if only that gal from Kazakhstan hadn't dropped our class, we wouldn't have to do all this work.
Yeah, there was a guy on Yahoo Answers who
Really? Maybe I need to just man up and learn that way.
Okay.
Was he from Kazakhstan?
did it. I don't know.
Do they allow
Okay, so if I FOIL this out, then I get this times this would be, the negative's going to go through, right? So it's negative x minus 6
What are all those numbers?
Wait, so
Signs
why?
for?
equals,
why negative?
because the square roots cancel, and a positive times a negative is a negative, and so you go negative x minus 6 because you have to bring the negative through, okay? Then inside cancels, outside cancels, I hope you understand that, okay? Plus x squared, and that's still going to be all over x squared times x minus 6.
But don't we have to multiply the bottom by that?
Yeah.
Yeah, but I don't want to do that. Remember I said don't
Oh,
ever,
yeah, but
I'm
you
going to
still have
write
to
it.
do it.
Right, but don't ever actually do that multiplication. Okay? Because you want this stuff that's going to cancel with this stuff here. Okay? Okay, so what I'm going to do just to make you a little more comfortable is I'm going to rewrite the top polynomial in the form that you're used to. And now I hope you can see that when it's written like that, what can I do on the top? I can factor out the top. So this factors into x minus 3 times x plus 2. So the x minus 3's cancel. And then now I can just plug in 3. So on top you get 5. And on the bottom you get 9 times negative 3 minus 3. So it's negative 5 over 50. Because minus 3 minus 3 is negative 6, and negative 6 times 9.
Negative on top.
And so here's a good reason why you would not want to use your calculator to solve this problem. Because the chances of you coming up with negative 5 over 54 as an exact decimal are very small. Okay? Because I mean, it's easy if it's going to be 1/3 or 5, right? But you don't go, oh yeah, that's approaching, you know, negative 0.05827, which everyone knows is the common fraction. Negative 54. Negative 5 over 54. So sometimes you got to just buck up and do the algebra.
I got 0.
All I got was a rock.
But I think I factored the bottom wrong.
What's the matter?
Something.
Okay, so same drill, right?
put 1/2 of this.
Same thing, right? Can't plug it in,
Conjugate.
so I'm gonna multiply by the complex conjugate. What's the matter, Theodore?
So when you multiply the sine square root of that square root.
Okay, so let's do this.
Let's do this.
Wait, why did I? Yeah. What? Why is that not negative? So.
Why is what not negative?
So it's just 16.
No. No.
16 minus s.
Yes. 4 times 4 is 16. Negative square root times positive square root is negative number.
Then 16 cancel. No.
Close. Remember that trick that I did on the last ones that freaked you out? I'm going to write this as negative 1 times s minus 16.
Oh, that's right, because you don't want to.
But I can't cancel a 16 minus s with an s minus 16 because they're not.
You're writing the top is
Yeah.
Yeah, I'm running the top.
Why don't the 6?
I know, they should be never allowed to use s's as variables in any math class. What? Okay.
So now they cancel.
Now they cancel out. Okay, we get negative 1 on top. If you substitute the 16 in there for the s, you get. You might be able to find on the calculator negative 0.125. Why is it 16 minus s? Because 4 times 4 is 16. The inside and the outside cancel. And then the square root of s times the square root of s is s. But it was a negative times a positive, so it's negative. Okay?
Back to the bottom.
Yep. And how about the top too?
I think I factored the bottom wrong.
Struggling with the double difference.
How's that work?
How are you really
Like a
slow
formula
way?
thing for that?
Yeah, maybe. Okay, let's do the top first. That's the easy part.
E plus 4 minus 2.
Okay? And then the bottom factors first into v squared minus 4 times v squared plus 4. Right?
Yeah, that's what I did wrong. I just made it all difference of 2 squares, like the same.
Which is what Mary did on the other problem, and then she double factored it. And yeah, so you have to remember that you can only factor the one thing.
But that's what you said yesterday, so difference of 2 squares twice.
So that's a bad way to say it.
That's
Difference.
what I applied.
Okay, sorry.
It's our fault.
That's my fault.
It's a
Okay, so yeah, it's not the difference of 2 squares. It's not the double difference of 2 squares. It's the difference of 2 plus. And then this becomes v minus 2 times v plus 2 times v squared plus 4. And now you should be able to finish it on your own. Yes. 3/16, is that what we got?
I'm going to say agreed.
Agreed?
That's what I got.
Affirmative?
Wow. That's ridiculous.
15 looks exactly like 7 problems that we've done already.
Yeah, but I'm understanding now.
Okay, so it's working.
Yeah.
We're-
It's so crazy. It's just,
Stupid comedy. This looks good.
huh?
We do the stupid comedy.
Yeah, we do the stupid conjugate thing.
It's 1 plus.
I know, but I didn't do.
So you get 1 plus 1 minus x.
Nope.
What's that all say? You get 1 minus.
You get
1
1 minus 1 minus. And then that means I can rewrite the top because the 1's cancel as x squared.
Yeah.
No, because the negative times the negative will give me positive. Nice try. Count on.
So then
Why is it negative x
Why
squared?
is it not negative?
Because this minus times this
No,
positive.
why is it not negative x squared on
Because the negative times the negative is positive.
well, now what do we do? Because it's 0.
So this x cancels with one of the x's here.
It's still going to be 0.
But it's 0, now it's not 0 over 0, it's 0 over 2.
1 minus 0 is. Got it.
Okay. Moving up in the world. Try and plug in one, no, it doesn't work. Okay, so then you need to figure out some algebra that you can do. And in this, we're going to get a common denominator. Okay? So this factors into
X minus 2, x minus 1.
x minus 2 and x minus 1. All right? So what will my common denominator be?
X minus 2, x minus 1.
X minus 2, x minus 1. So this is, like I said, it's like a big old algebra review class.
This is what I did, and it didn't work, so I was sad and gave up.
Okay, now, last year's class did create a Facebook group, and then they could communicate with each other. What's that? What?
It's not
What happened?
About Andrew.
Well, it's about English.
We could do about English when we fall asleep during the story sheet signs.
All right, so your common denominator is going to be x minus 2 times x minus 1, right? So, common denominator, okay. So, this already had an x minus 1, so I only need to multiply by x minus 2, right? So 1 times x minus 2 is x minus 2, and I'm done with that. Okay?
Yeah, you're really.
I didn't get very tired.
Here.
Oh, the other one stays one. Yeah, that's what I did. Oh, you can't plus 1. Yeah.
You know where we're going now? You seem like you do.
X minus. I was gonna say it'll cancel a lot of 2, but you can't.
At
You
the
just
top,
put
you
it.
can only add a root.
Right, I can add them together. So x minus 2 plus 1 is,
Yeah. Okay.
What is the x minus 1? What is the x minus 1? That's what I got.
Yes.
Yes, fish, gosh.
yeah, Trish. Oh, what do you think this is?
Now I understand why it's really crisis.
Are you ready?
No.
Well, okay, now, you guys need to do better. And like, can you not copy down the problems before you come to class, at least? I mean, it's one thing to not do your homework, but can you at least have it?
I think I
You don't know how much room you're gonna have.
I went to 24 and then.
It's stupid, Trish. God.
Okay, this is going to be a quick one. Bless you.
I don't
Are you ready?
understand all of
Yeah,
this.
go ahead.
I don't understand all the lines.
Okay.
It was really that easy.
Why?
I thought it was too easy that I thought
It's the sandwich theorem.
This is,
I
I don't even
really
know.
don't
The squeeze theorem. Yeah, it's a really dumb example. This is smaller than this is bigger than this in a range that's close to where we want the limit. So that means if you plug in 1 to here and you plug in 1 to here, if you get the same answer for those, then you're going to get the same answer for that.
What's your name?
It's just one.
I like your principles, that's.
Okay?
Yeah.
Okay, so for 18, it's going to be the same deal. Okay, same deal. Now you have to do the work.
If I get 0, you get 0.
Well, you can't.
You can't because that.
You can't have a 0 here. Right, so 0 times anything is 0. Right, but you will learn later in this class that sometimes 0 times infinity is 0 and sometimes it's 0. Okay, so here's the easy way that we've done these before. With the steps I'm about to write. So here's my first step. We know that -1 is less than or equal to the cosine of 1 over x squared is less than or equal to 1. Yes.
And then you multiply that.
Right.
What is this? I don't remember.
That's my first step in my proof. Or in my show. Is it a proof or a show? It's a proof. Okay, so that lets me say that -x squared is less than or equal to x squared times cosine of 1x squared less than or equal to x squared. Okay? Multiplied everything by x squared. Why? Because that gives me my original. I want those to match. Okay? And since the limit as x approaches 0 of -x squared equals 0, and the limit as x approaches 0 of positive x squared equals 0.
What I done yet?